So next up, we have Mátyás Selmeci from here at CHTC talking about placement tokens.
There we go. Hi, everyone. So yeah, I'm going to talk about placement tokens, capability-based authorization for job placement. And this is not advancing. Is it on? Trying to use the keyboard. I'll just click. Oh, no. Okay. And this is some experimental work we've been doing in the past year or so. So not a finished product, but you can think of it as groundwork for future improvements. And the idea is to make it easier for users to gain and have access to an access point services. And I said specifically services. Keep that in mind. I'll get to why later. But the motivation, one motivation for why we're doing this work is, imagine a classroom environment. Imagine like a semester-long, domain science class of 30 people. They're going to need access to HTC to do their work, but they don't want to use the command line, and they shouldn't have to. And so we want to give them the ability to use HTC without giving them shell access on a Unix machine, or giving them yet another username and password to remember. And so that is why I mentioned services. We don't want to give them access to the access point. We want to give them access to what the access point provides. I want to give them this access, for the duration of the class. Give them at the start, revoke it at the end, and yeah, just not have an account that has privileges that they don't even want to use. So first, let's go over where we're at with Condor. How much can we already do with to achieve this? You can already place jobs without having to log into an AP. It's called remote submit and remote placement, but it has limitations right now. The big one is that the job in the queue is still owned by a user that's an operating system user on the access point. And even if the user does not log into the access point, they will need an account on the access point. There isn't really there's no real good reason for that. And so because of that, when they start the class, the AP admin must provision their account. When the class is over, the AP admin must deprovision their account. And in the meantime, so they can use remote placement, the AP admin must create and give them some sort of credential with which to do that. So yeah, there's some improvements to make. We've already started down this road years ago. The idea of an access point user has already been part of Condor since at least 10.6. You've got the Condor Q users tool that'll, and so Condor already has its own database. It shouldn't need operating system users. The one limitation of AP users is that the name of the AP user had to match the name of the operating system account. There's no good reason for that limitation, so we did some plumbing work to get rid of that. We've added the ability to create generic accounts, user 1 through user 100. Instead of an AP user having a permanent assignment to a Unix account, it'll be kind of dynamically assigned when they place a job, and unlinked when it's no longer needed. Um, if you think of execution points of slot users where each job on a different slot runs as a different user, this is kind of the same thing, but for access points. And the second thing we want to do is to address the admin having to give the user a credential. Instead, we want to give the user a way to obtain a credential for themselves. And that is actually what I'm going to focus on in the rest of my talk. So self-service credentials, before we get into that, let's take a step back and talk about why and how we need credentials at the first place. Rather, what needs authorization? The obvious answer would be that a user needs authorization on an AP. But if you think about it, a user does not place a job by themselves. A user runs some sort of program to place a job. So really, it's that user's program that needs the authorization. And furthermore, a user doesn't just run one program, a user runs multiple programs. So some of the user's programs need authorization. And not all programs are created equal, so not all programs need the same authorization levels. So really what we should be saying is some of the user's programs need some kind of authorization. Some of the time. And yeah, so not all programs need access to the same things, and in fact, programs that don't need access to something shouldn't be given access to something. And this is the idea of the principle of least privilege. Give users and programs only the access they need to do their jobs and nothing else. So when we want a security model for how to achieve that, we already have one. It's called capabilities. So I'm going to give like a 1-minute overview of what a capability is. It's basically some kind of object, frequently called a token, that provides whoever holds the token the authorization to perform a certain set of actions on a certain resource. These are all very generic terms because this is a generic security model. But one thing I want to point out is that the set of actions and the resource are linked. So you don't get a capability that lets you do everything to X, and you don't get a capability that lets you do Y to everything. You get a capability that lets you do Y to X. And the usefulness of capabilities is they can be handed out. They can be delegated, copied from a user to a program, from a program to a helper program, or from a user to another user. And one thing I mentioned that while the actions and the resource are linked in the capability, one thing that is not linked to the capability is the identity of whoever requested the capability or whoever's capability it is. Merely holding and presenting the capability or proof that you have it should be sufficient to grant authorization for the actions. So Condor has already had tokens for a while now, and they look like capabilities at a distance, but not really. ID tokens, as the name suggests, actually contain identity, and they're used for proving the identity of the bearer. And they're not really capabilities because what's actually used for access control when an ID token is in use is the identity that's inside the token. And so, when an ID token is presented, Condor gets some sort of identity, and it's checked against the Condor's config knobs, allow write and deny write, and that's how you check to see if the presenter has access. And yes, you can restrict it. You can restrict the access via scopes, but it's still not really that matters. And one of the other issues with ID tokens is that there's is that there's no real keeping track of them. When you create an ID token, it gets logged in a text log. If that text log gets lost or rotated or is on an ephemeral volume, you don't know anything about the token. How about we improve on this? Since we're aiming for the specific use case of placement, we'll make a new kind of token, and we'll call it a placement token, which will behave more like a pure capability. Placement token, once you present it, if it has a name in it, that name will be ignored for the purpose of authorization. If the token says you can write to X, you will be able to write to X no matter what the name is. And if you present a placement token, the Condor config options, allow write and whatever will be ignored for that. And so this makes placement tokens a more powerful credential, but it also means that you have to take more care when issuing them and take more care and keep better track of them. So the way we're doing that is we created a dedicated daemon for making placement tokens. It's called the placement D. And the placement D is going to have a table of usernames. It's going to have what authorizations those users should be able to acquire. And it's going to have a database to keep track of all the capabilities of all the tokens that it's created. And so only the placement D will be making placement tokens, nobody else can. And before it makes a token, it will look up the user in the table. The placement, if the user is not in the table, obviously they don't get a token. If the user requests some sort of access that they're not supposed to request, they don't get a token. If the user's access has expired, they don't get a token. After granting a capability, creating a token, it will record the in its database the creation of the token, who requested it, what AP user it's for, what authorizations it has, what and when it will expire, any other data that we or the AP admin or the auditor may find useful. And in fact, it is this database that the Condor daemons, the SCED-D, will look at when the placement token is presented, and they need to validate that it's a legit token and that it should give the holder the authorization to do whatever they want to do. And because it's in a database, it means if you remove the entry from the database, then the token is no longer valid. There's no token without a record. If the log gets lost, then the token is just junk. So now that I've described kind of how placement tokens implement capabilities, I'll go back to why we might want a user to have self-service capabilities. And I've already mentioned that capabilities are given to programs, and the user may run multiple programs and they'll all need different capabilities. And the AP admin, who usually centrally controls the user's access, does not know what programs they'll run, definitely does not know which programs will need which permissions. The user is in a better spot to know that. So it's the user who should be able to obtain these capabilities by themselves and then hand them off to the programs that need them. So now that we've described why, I'll quickly go over how. We've already said that we don't want the user to have to use a command line. So we created the placement website, which is kind of a web front end in front of the placement D. And because, like I said, we don't want to give the user yet another account and username and password, what we want to do is let them use their campus identity provider, single sign-on, to give the placement website the name for the user, which is really all it needs. And the name can get passed on to the placement D. So I mentioned that the placement D has a table, and this is kind of what the table looks like. And the table is keyed by the name that the placement D is given via the placement website from the identity provider. Hopefully, I've explained why merely controlling who is allowed to get a token and when should be sufficient for controlling access. I'll go over a little bit about what kind of a win this gives us. If we want to go back to our example of our class of 30 domain scientists, if you want to give them access for a limited time, you just add them to the table, give them an expiration date. It'll last as long as it lasts, and the authorization will be removed when it's removed. Also, moving away from using Condor knobs for access control gives us the groundwork for being able to create, more custom, more fine-grained authorization levels. I'm going to skip the summary because I'm out of time, but I want to say a big thanks to Todd and Jamie and our fearless leader, Marone, for all the work and help and advice with this project. And I'll open it up to questions.
Hello. Thank you for the talk. This is Andrew Mello from Vanderbilt. So I see that you kind of have two things, right? You have the token, the thing that's actually getting passed around, and then somewhere else you have this database that keeps some information. Does this imply that if the database disappears or blips out for a little bit, the token, there's no way for the other side to actually verify that the token is actually valid, or how is that handled?
Right. The holder of the token will need to go and ask the placement D, is this token still valid?
Hi, Matt. Is the I'm not sure what level to put this is. Is the placement D intended to be per AP, or is the database meant to be per AP, or could you have these things sort of?
Yes, the placement D is a daemon that lives on an AP. There will be one placement D per AP, and the database will live on the AP and will be read by the placement D and the sched D.
Clarification. AP doesn't mean sched D, as Todd says. And the key is that the AP, or let's say the sched D here, is because it's the one that does the authorization, trusts the issuer, the placement daemon, when it gets information about the capability. And the capability is not a question of is the capability valid. There's no secret in the capability, except for it is a unique or a difficult to guess. I prefer to call it a cookie, like you have in the web world. And the meaning of the cookie is stored with the server. So when you show up with the capability, the server knows what can be done with this capability. Okay, so there are no identifiers associated with it. By the way, I am on a crusade that, at least within CHTC, we don't talk about identity. We only talk about identifiers. I would argue with what you heard about CI logon. CI logon has no idea about identities. And it turns out that InCommon also in some places has no idea of identities. All it knows is identifiers. And whether there is an identity is one as a person, identifiers, you have different credit cards, and that's your identifiers. And we really are only managing identifiers. We have no clue about identity.
Any other questions for Matt? All right, let's thank him again.